first flip-flop is already done in the last class, that is SR flip-flop. Is that correct? So even if you want, you can try with a NAND latch. Then also you will get two indeterminate states. Most probably it will be 0, 0, 0 and 1, 1, 1. Is that correct? It is 0, 0, 0 and 1, 0, 0. Which one? If at all we use NAND latch. See, by this time you should be well versatile with that. If you use NAND latch, 0, 0 situation like Q of T, S and R. This also will be indeterminate. This also will be indeterminate. Is that correct? If you use NAND latch.
Yes, ma'am.
Please verify. Yeah, please verify that. Okay. So anyway, we will proceed further and then try to evolve, or means evolution has been done in the flip-flop theories. So where they have developed a next type of flip-flop called delay flip-flop. Right. So in short, it is called D flip-flop. Delay. D stands for delay. Now, a delay flip-flop is nothing but in general. Okay, whatever the input is there, that has to be produced at the output. Right? But it has to be delayed. Now you can ask a question, why we require a delay? Right? Delay circuits are very well versed used whenever we do parallel processing. Right? Now, for example, you are doing some operation on another take arithmetic and logic unit, ALU of that. You are doing parallelly another operation in another portion of your ALU. Okay, but your result, okay, one of the result has to wait till the other result comes. Right? That means it has to be delayed. In fact, you can say it is a buffer also. Right? Buffering is what? You will not alter that signal, but you will use it for later without altering the signal. Is that correct? Buffer means same thing. We will go with the delay also. Now, delay flip-flop is normally developed from the SR only. It has been evolved from the SR flip-flop. Only small changes they have done. Okay, so from the SR flip-flop to the delay flip-flop, no much changes. Only thing is, we can use NANDs also here. And afterwards I will explain you with the NORs also. So what exactly is procedure is, they use the initially they have utilized a NAND latch, right? Okay, so now this is the latch, right? This is your original latch. For this one, I am using a NAND operation, right? Q and Q bar, right? So instead of NOR, we have NANDs. Okay, so these are the two gates. Now, gate 1, gate 2. Now, gate 1 and gate 2 will receive the signals externally, SR, through a clock. Is that correct? In your SR flip-flop. But here, it will be receiving another 3 and 4. This is your clock. Now, this is your signal B. Now, this is your signal. Now, this is called clock pulse. Right? Now, carefully understand. This is the extra addition. This is just a modification of your SR flip-flop where a NAND latch is used. Right? When a NAND latch is used, a little bit difference is there. Okay, in the execution. But anyway, that's very easy to understand also. A NAND latch is used. Then afterwards, the SR flip-flops are directed into the NAND latch through a clock pulse in this manner. In this manner. Now, what is this manner? Extra gate 3 and 4 are used with the NAND gates. See, please try to understand. This is not a what? One and only D flip-flop. We can create like this many. Our main aim is what? We have to get an output exactly whatever you give in the input. Now, if you see how many inputs are there here, please tell me how many inputs are there. Why you are silent? Yes, only one, right? Whereas in your previous flip-flop, what is there? 2. present
Yes,
R.
ma'am.
Whereas here we have only one input. What happened to the other input? Simple. The other input is actually the inversion of your single input. So your two input flip flop SR has been modified to a single input flip flop. But exactly, it is actually the same signal and its inversion is fed here. If you carefully observe, this is also an AND gate, a single input NAND gate you can take. So this one is nothing but a delay flip flop, and if at all you understand its operation, how exactly it will work. This is what we are trying to understand. Its characteristics are like this. So previously we will have 0, right? And input is 0. We will give that. So what will happen to this? So clock pulse as usual 1, right? So now what will happen? D is equal to 0. So what will happen? This 0 will come here. This one is coming here, right? Is that correct? CP is 1 high. We will keep. Okay. So high we will keep, and this is also 1, and this 0 will be there. This is 1. Now what will be here? And by the way, here it is already 0. We have to estimate what will be Q of t plus 1. Now can you tell me what will be Q of t plus 1? What will be here? What it will receive? What it will receive? From here itself we can say 0 and 1. You will get 1. And here you will get 0. Is that correct or not?
Yes, ma'am.
So what will come? 1, 1 will be there here. Here it is 1, it is 1, and then output will be 0. This is the new Q of t plus 1. Is that correct? Is that correct or not? You can evaluate. For this circuit, don't memorize anything. I have given you the circuit. Consider that 0 is there already, right? Then D is given 0. Evaluate what will be Q of t plus 1. This should be the evaluation, right? Similarly, you can evaluate what will be this one, 0 and 1. What is 0 and 1? So in order to evaluate that, again, you erase this. Okay, so again do the procedure. Now what is that? Q of t is again 0. We are now going to evaluate what is there here with the d equal to 1. D equal to 1, this is already 1 all the time 1. This is 0. This is 1 here. So 1 here and then 1 here. So here it will be 0 will be coming here, and here it will be 1 coming here. Now tell me, what is coming here? This will be, if this is 0, this is 1. Huh? So you will get, even if you take also, what will be happening? This will be, is it coming 1? Will it be 1? The next state, Q of t plus 1. Why everybody is silent? Will it be coming 1 or not? Good.
Yes, ma'am. 1.
Very good. No problem. So you fill up. You see, if at all you want to interact or don't want to interact, it becomes little what? Pressurized. Okay, if you interact means I at least feel the 1 or 2 or people are listening. Now though you people are not even responding, God knows. So I have to go for assignments and assignments. That's all. Right? Try to interact. So 1 0. So what will happen here? For 1 0, again you do the procedure. Don't copy anything. It's available in the internet, but don't do that. So you have to go through this. Right? So sometimes I will change this latch and ask you to evaluate it. So that also will work out. Now tell me. For this situation, 1 and 0. So Q of t, this is 1, right? And D is 0. Now rest of the things.
Zero.
0, it is coming.
0.
Okay. Then 1 1. No. So 1 1.
Don't care.
Don't care. What happened?
1. Yes, ma'am.
Ma'am,
1.
1.
Who told don't care? It is 1. It's coming 1. Now, if you observe, sorry, this is coming 1. If you observe, whatever D is there, that only is fast here. Did you see? This is 0, this is 1, this is 0, this is 1, irrespective of whatever previous state it is. Don't you feel?
Yes, ma'am.
So, this is what the delayed flip-flop. Now, see, this is somebody has proposed and we are understanding it. Now, we should be able to think for ourselves. Now, completely understand here the logic behind it. What exactly is done? Instead of 2 inputs, single input is taken and its inverse is sent here. Right, in the 5th gate, concentrate on the 5th gate, it's a NOT. Right? Then afterwards, 2 NANDs are proposed. If these 2 NANDs are there, why NANDs are used, why can't we use AND gate? We can use that also. No? This is a gated latch because clock pulse is gated through this. Right? And this is your NAND latch. So 1 and 2 is the latch. Then this is the gated version and these are the inputs. Don't you feel that? So we have every levels. So first the input level, a direct one and a inverted one. Then comes your gate. Gate is the clock pulse inputs. Then comes your latch. Right? Now, can you suggest to me any changes in this? But whatever data I give, it should come at the Q of t plus 1. What changes I can propose here? Come on. Now, if at all you're really thinking and not working out into the what? Internet sources or anything, now you propose. Can I use AND gate here? Then also get the same thing? Simple question. See, we need to alter, right? Whatever is there in the book, if you study, nothing works. Where is our analysis there? See, what I was telling is, can I change these 2 to AND gates? Can I change and still maintain the same thing? Immediate, if you can just draw the circuit and check out. Right. See, BTECs are supposed to be very fast. Not like your PG, not like our PG. Check out. Come on, do that. Karthikeyan.
Yes.
Ma'am, I have a doubt.
Yes, go ahead. I want your inputs, please. Go ahead.
Hello.
Yeah, I'm listening.
Ma'am, the second inputs is 0, 1.
See, I have the number of the gates now, you just tell.
No, ma'am. Table. I have doubt in table.
Okay.
When we apply, when the memory Q of t is 0 and d is 1, I am getting both q and q bar 1.
No, impossible. Okay, you have a doubt. So let's see that. Okay, so I will hold this question for a minute and then Karthikeya has some doubt. In which one? In the second row? In this row?
Yes, ma'am. Yes, ma'am.
Okay, let's see. D equal to 1, right? And Q of t is 0. Okay, that's what you right. So if this is 1, this will travel here 0. This will travel here as 1. This is 1. This becomes 0 here. This becomes 1 here. Right? If this is 0, the NAND property is what? The NAND property is to show output. Any input is 0, output is 1. Na? Why you are getting like that? This will be 1 definitely. So why you are getting 1 and 0?
Ma'am, you are taking for one gate number 1. If Q memory is 0, then Q bar memory will be 1.
If this is 1, so what? If this
So
is 1, that is Q of t, na? Q of t. So if this is 0, Q of t, Q bar will be 1. Yes, no problem.
Then if I am checking for gate 2, Q is 0.
Gate 2, Q is
हाँ
0.
0 1 0 1 will be 1
Correct
and
only. That is a
and
T.
Q.
That is a, wait. That is a T level. Now I am talking about T plus 1. See, if this is 0 here, if this is 0, this is 1 only. That's why it is satisfied. No? That is in the T level. T level, you move to T plus 1. T plus 1 is the state where D is entering the show. D is entering the show. You are calculating only at the T level. I am wanting you to do at T plus 1. T plus 1 will be working out only when D will enter. No? Is that correct? See, even whatever you are telling
I got disconnected. What I'm saying is, uh, I am getting Q T plus 1 and Q bar T plus 1, both 1.
can't be possible. Can't be possible. How? You tell me. See, here,
Ma'am, Q bar is 1.
see, you tell me Q bar of T plus 1 and Q bar of T plus 1. This is what you are wishing, correct? So first, let's see one by one. Sorry, Q of T plus 1, Q bar of T plus 1. These two are coming 1 for you. Is that correct?
Yes, ma'am.
Oh, now, that is what I am telling you. So now, this T plus 1 will be evaluated only when D will enter. Is that correct? That you will agree? Yes or no?
Yes, ma'am. Yes, ma'am.
Okay. So D has to enter. So till that level, this is all in the T state. Okay, now we are in the T state. In the T state, the situation is like this. So clock pulse is that D is not entering at. Okay, so this is 0 already. That means it's obviously 1 will be there. That is the T state situation. Okay, you need not show the Q bar because it will be much more confusing. And if you see, I am following one thing. There is a task like here and next. I am writing here this side, both sides separately. Okay, now you understand. So this is the T situation. So at that time D will be equal to 1. D is 1 is entering. If 1 is entering here,
Ma'am, I'm telling the outputs like fast so that we'll save the time. Third input will be 0. The
yes,
gate third will be input 0, and that
yes,
4 will be 1.
4 will be 1.
Then
Yes,
we'll check for second
what
0 1
why is it? Okay.
0 1. The Q
1.
bar will be 1.
Q bar what? Q bar means what? T or T plus 1? That you tell.
Q bar of T plus 1 will be 1 na.
Q bar of T plus 1 will be 1. How?
Ma'am, if we are taking Q of
No, no,
T0,
I am not understanding. If the 0 and 1 enters this latch at the same time, why Q bar of T plus 1 you are calculating? This NAND gate reacts for 0, no? That is what the theory. So 0 is entering, 1 is entering, irrespective of whatever, one of the input is 0, the output will be 1. So this is your T plus 1. Is that correct? So you are telling that here 1 has come, so you will take 0 over here, and then afterwards 1 is coming, that will be Q bar of T plus 1, and this will go here, then afterwards 1 is coming. Then you are telling these two are in same state. Is that correct?
yes, ma'am. Yes.
Wrong. That is wrong. So your analysis is wrong, no? Because I already told whenever an AND and a NOR latch, you understand the working of a latch. Till here the level is there, and this is the latches work. Latch work is what? If the NAND has any of the input is 0, irrespective of whatever input is, it will show 1. It will react for that. Yes? So in that situation, T plus 1 will be 1. It is showing 1. Right? So whatever you are proposing, this 1 will come here and then output will be 0. This will be Q bar of T plus 1. Okay? So you could understand. Say earlier NOR also you have done the same value. So why you are having an objection here? Only in this level. Work out again. Okay?
Ma'am, but Q of T is like it was previously there only na. So
Yes.
how it will react for like if I'm telling the D will enter, it will take some time to go in 1 and 2. So Q of T is already there.
Kartikeya, please wait. It will take some time. It will react at that. Are we following any timing diagram now? As of now, we were only saying in words. Timing diagram means at that levels, right? We have a clock pulse. At that instance, what is happening, we can draw. So that has a clarity. But you are telling that they will wait for some time in 1 and 2, but 1 and 2 will be different. This is all don't work out in words. It has to go with the timing diagram. Are we following any timing diagram? No, no. We are only following one truth, that if a NAND latch is there, if any of the input is 0, output will be working on. If NOR latch is there, if any of the input is 1, output is 0. This is what the truth is at present. Once we go further and analyze more using the timing diagrams, then you will get the clarity. Definitely, it will not work out Q of T plus 1 because it is there. This will go here and then this will be evaluated. Otherwise, this is there, it will come here and this will react. How it is possible? When they are together there, they will come together, not here. Together it will be there, and how together it should react in that case. Q and Q bar complements to each other, but it will not be determinant. And by the way, if at all you had a problem here, you should be having a problem here also, no? Is that correct? Hello?
Yes, ma'am.
Did you have a problem here also?
I
No.
did not calculate that.
So you calculate that also. Definitely you will be getting problem here also because your statements are like that. Are anybody else is having problems like that? The whole 96 class keep mum. God forbid.
Hello,
Okay.
ma'am.
Yeah.
Ma'am, we can replace 3 and 4 by AND gates, and we can place 5 that NOT gate in above, means before 3.
Just a second. Who is speaking?
Dinesh.
Okay, Dinesh is the earlier one before AND. Is that clear? First of all.
Yes, ma'am, it's fine.
Okay. Now you tell. Now. Yeah. Go
Ma'am,
ahead.
ma'am, we can replace 3 and 4 by AND gates, and we
Hmm.
can place 5 means before 3, means in
Okay.
the
So
above.
yes. Then also your same table will come. Characteristic table will be same.
Yes, ma'am.
Oh, good. Let's see. So his proposition is something different. So you
Ma'am?
are telling, yes.
Excuse me,
Just
ma'am.
a second. Yes, ma'am. Go ahead. Go ahead. I'm there.
Ma'am,
I'm there.
I think we have to replace also 1 and 2 with NOR if you have to work with AND gate in 3 and 4.
Oh,
If you are
somebody
clear.
else. Okay. So I think Dinesh is not done. I think Dinesh is still continuing. Yes, Dinesh?
Ma'am,
No,
this is
ma'am.
Avijit.
No, this is Abhijit. Okay. So this is clock pulse. So this is an AND one and sorry. This is his proposition 3 and 4. I just wanted that. And now the latch is also has to be what?
Ma'am, for me, for Dinesh,
No?
means it is a NAND gate only.
This is one.
Ma'am, for me it is NAND gate. The latch will be same, remain same.
Acha. For one people, this remains same. It seems another one, it will be NOR. Yes?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
So which is correct?
Ma'am, I think I am correct.
Ma'am, I
Please
think
that
I am
I.
correct.
I think I am
Ma'am,
correct.
Dinesh means
Avijit.
Dinesh is correct. So third person, we want a third one. Third
One
and
of
final review. Right?
One of
So in the class of 100 plus, nobody is acting as a third and five?
Ma'am, NOR gate is correct.
NOR gate is correct.
Yes,
So who
ma'am.
get it?
NOR gate is correct.
Swastik is telling
Yes,
NOR
ma'am.
is correct.
I own.
NOR gate.
NOR gate is correct.
NOR gate is correct, I think.
Ma'am, but
Yes,
with
ma'am. It
NAND
will be
gate also
NOR.
we are getting.
With NAND also is coming. So draw. Match is draw.
Ma'am, I think it will work only with NOR.
Oh.
With NAND it is not coming. Ma'am, with
Yes,
0,
ma'am.
1
NAND it is not coming.
Yes,
NAND
ma'am.
is
Only
not
with
coming.
NOR.
No, ma'am.
NOR it is.
Good.
Yes, with only NOR is coming.
Yes, ma'am, with only NOR.
Only now. So this is correct.
Yes,
What I
ma'am.
have drawn is correct.
Yes, ma'am.
Yeah. Yeah, that's all. By default, I can be wrong. Okay, so anyway, question comes, we can prepare like this delay circuits. This is called delay flip-flop, that's all. We are delaying the input, that's all. We are trying to work out in a delayed manner. Okay, just like our online classes. Delayed manner, we are wasting time. Okay, whether you take NAND, you can take NOR, whatever it is. Option is, instead of two inputs, we took the same input and then got the delayed version of the inputs. That's all. So this is what a characteristics of a delay flip-flop is. Right. So now, what is the improvement you found from SR to delay? At least we have avoided the indeterminate state. Is that correct? But at the cost of only now it became a single input. Instead of two inputs, we got only one input now. Earlier it was two input circuit. Is that correct? S and R. Now we have a single input circuit. Right? So this is what the second proposition was. Right? To delay the signal. Just to avoid the indeterminate state. Right? But that didn't suffice the work. But there are still some more improvements Jack has done. Okay, JK. We will say J and K. Who are J and K? Jack and Kilby. These two are friends, I guess. I don't know. They proposed one more flip-flop. It's very simple flip-flop. Okay, they used a feedback concept. What it is? So, a feedback concept with AND gates and the same clock pulse. Same NOR. Okay, now your latch will start. And Q bar over here. Right? Now, this one is the feedback. Now, please try to. This is already existing. It's like this. Okay, now, hold on. The feedback means it's a part of the circuit. Don't think that it is afterwards. Now, feedback is already existing in T and we have to analyze T plus 1 along with the feedback. Please try to understand. T and T plus 1 incident, if at all you are analyzing, it is with the feedback and along with that, we will have to take the feedback also into consideration. So now, two inputs, two external inputs, one is J, another is K. Jack and Kill. These two have proposed it. Right, and NOR latch, afterwards we will do the modifications, that's not an issue. Now if you see, clock pulse as usual maintain high, it is maintained high, right, and the input circuit is like this. And NOR latch, 1 and 2 you can take, 3 and 4, AND gates. Right, now Q and Q bar is like this. Now in order to analyze this, what we have to do, we have to go back to the characteristic table, then afterwards, what is Q of T, J and K, then determine what is Q of T plus 1. Okay, go step by step. Don't get confused. Right. So first of all, even if you analyze any portions, right, afterwards every gate output you try to write, then evaluate. We have T and T plus 1. I am purposely avoiding Q bar. Why? Because it increases the burden. Right. If at all here we will see again we will try to do and then maybe we will be pushing to T plus 2 state. Right. So that's why Q bar writing I am avoiding. It's a good habit. If at all Q bar if you don't write, analyzation is very easy. Okay. Now let's see that. Q bar of T means what? So that here I am writing green pen. So we will have here 0. That means it's a part of the feedback. That means 0 is already here. Okay, because this is a feedback existing. So here 1 will be there, here we have 1. I will not write 1 here, but obviously we will get 1 here because feedback is from the Q bar. Please try to understand. J and K both are zeros in the first incident. So 1 is here, this is clock pulse, 0 has come, this is, what is that, 0 and this is 1. Did you understand what are the inputs of 3 and 4 at present? How did I write? I'm just following the lines. Please try to understand, it's in green for this incident. 0 is here, J is 0, K is 0 and I have written what are the inputs to the 3 and 4. I didn't calculate the outputs yet. Is that correct? Everyone?
Yes, ma'am. Yes, ma'am.
Correct?
Yes.
So now this is the situation of T instant. Now carefully understand. I have written 1 here means obviously T instant it is 1 only. But I am avoiding to write that. Please try to understand. There's a feedback path. Feedback path. So 1 has come here, this one. Now what is the output of 3 and what is the output of 4? Both are zeros, na? Output of 3. 3 means gate 3, gate 4.
0 both.
Yeah, that's what. This is 0. So the latch is receiving 0. Is that correct?
Yes.
Yes,
ma'am.
yes or no? So 0 over here, 0 over here. Now our aim is what? We have to find out what is Q of T plus 1. Okay, that 0 who is existing there is Q of T incident. Right. Now what will be Q of T plus 1? What is the NOR property? If any of the input is 1, output is 0. But as such, we didn't receive anything like that. Is that correct? So now, if you see here carefully, you have already existing one here, which is in the T incident, that is already existing here. Now you tell me, this particular one and this particular one reaction. First one reaction of T plus 1 incident. What will be there? 0, na?
0.
Yes. Obviously, this will be 1 only. Yes or not?
Yes.
Right? So now, this is how step by step you have to go. Please try to understand yourself. Okay, because I'm not, this is in an online mode, I'm not able to see your reactions. Please try to understand very slowly, one step afterwards another. Okay, so don't go in a sequence. Now, just for immediately, 0, 1, 0. What is its output? For this one, what will be Q of T plus 1? Again, nicely erase it. Decide what should be here. Then tell. Kartikeya, please try to concentrate now. Okay, don't get confused. Right? 0, 1, 0. Now J is equal to 1, K is equal to 0. Right? And Q of T is 0. Already there. So in this feedback is 0. This 0 coming here 1. So this is 1 here, J is 1 and here 1. Okay, so now I think these are the situations already there. Follow the lines. Now what is the 3 and 4 output?
Zero.
What is 0, 0? Acha. 3 and 4 output is 0, 0. How?
0, 1.
0 1.
Yeah, this will be 0 and this will be 1. Now you tell me what will be 2 T plus 1? Quickly.
1.
I am talking about Q of T plus 1.
0.
You have only 2 options. So one fellow has already given the value 1, another fellow is giving 0. So who has told 1? Can you have an what explanation?
Yes, ma'am. It will be 1.
0.
1, ma'am.
Ma'am, it will be 1.
Just a second, ma'am. Not property. Please try to understand.
Ma'am, 0.
Here, it's not again. Please hold on. Okay. Here, this is 1. Why? Because this is T incident. Okay. T incident. This is also T incident. Better write that way. Okay. Now, this NOR is receiving 1. This particular NOR 1 is receiving 0. Is that correct? Is that correct or not?
Yes.
Yes, ma'am.
Right? So who will react first? Who will react?
2.
See, second gate is receiving 1. Immediately t plus 1 is already decided. T plus 1 incident here is 0. So that means 0 will be here, here it will be 1. What exactly you are following? NOR latch I have completely told you it's on based on a single statement. If any of the input is 1, indeterminately it will be giving out the output 0. So that has to be coming immediately understood. That's what the NOR logic is. So 0, 1, 0, it is 1. Okay, so now complete it. 0, 0, 1, what will be that? 0, 1, 0, already done. No? Now check out this second one and this one. See, if at all, if you want me to show slides, 100 slides are available. Internet, if you click JK Diploma, you get the characteristic table. But you will not be understanding this. Please try to cooperate from your side. Okay. Already digital, my enthusiasm totally gone. Okay. With your response and all. Seriously, I used to enjoy my class. Gone case. How are we dealing with this? So what will be 0, 0, 1?
For second it will be 0.
So 0, 0, 1 is 0. So how you can say that? So 0, 0, 1 means everybody concentrate. So 0, 0, 1 means
0.
okay, it is 0. Right. So this is more important. 1, 1 situation in your SR flip-flop, it became indeterminate. Now check out whether we are avoiding that or not with that feedback. Okay, this is 0, fine.
It will be 1.
It will be 1. Okay, confident in that? It will be 1?
Yes, yes, ma'am.
So we are trying to see slowly we have to cope up with each other. Why? Because I'm not able to see your reactions. Otherwise, 100 times I would have explained each per number. Okay, that's not the point. So I'm not able to check out. In the internet, we will get the truth table or the characteristic table. That's different. No? We should analyze how we are going through. Right? So from here to here, here to here, how the signal travels, like what to be taken. That's why t plus 1. Every time make a point. T plus 1, T plus 1. So who are entering here, actually game changes there. Okay, are we getting 0, 1, 1? Very nicely, 1. Okay, one more situation I want very clearly to be done, 1, 1, 1. That one also. 1, 1, 1 situation.
Zero.
1, 1, 1 situation. Output
Ma'am,
is there.
0. Ma'am, 0 out.
And 0.
0.
Ma'am, 0.
Yes, ma'am. Good. Give the characteristic equation now. Now fill up all the incidents. Fill up all the incidents now. You told this and this is 1. This is 0, 0, 1. Okay, what about this rest? That much you have told. Is this coming 1?
Yes, ma'am.
So now, what is Q of t plus 1? Characteristic equation. You can take the K map and then work out. Just like yesterday's. And then the logic symbol. G is connected to Q. This is your logic. So what is Q of t plus 1?
J Q prime plus K prime Q.
J Q prime means K prime Q.
K prime Q, yes.
Yeah. Okay? Prime. Yeah, this way or this way. Anything will do. No problem. This one under. Is that correct? Everybody got?
Yes, ma'am.
Okay. Now, the next one is a very simple flip-flop. Right? First flip-flop, you have a setback of indeterminate state. Next one in between is a buffer. Right? We are delaying the signal, but we got only one input signal. So one input flip-flop. Now the third one is a simple feedback logic is used where we have avoided the indeterminate states which are coming in the SR flip-flop. Did you check out? We have a clear-cut idea like we have a level. We have a state declared, not like fluctuating. Is that correct? This is what the JK flip-flop is. Now next one is a very simple flip-flop called T flip-flop. Okay. Now so I will tell you in crisp. Take the same circuit, right? Take the same circuit. Tie J and K together. That means right. This is T. Whatever is going here, the same will be coming here. No alteration. Okay. Now this becomes a T flip-flop. New one. This is a new one. Right? Single input. Now analyze. Now analyze what it is. Q is there. T is there. Now what is Q of t plus 1? You have only 4 options. These are the situations we can face. Now what is Q of t plus 1? Analyzation is similar. No changes. Same feedback is there. Same signal is going to 3 and 4. That's all. For 0, 0 situation, what is coming?
0.
Okay. Next. Zero one. Somebody, is this 0 coming?
Yes.
For 0 1? For
0
0
1
1?
is 1. 1.
Okay. 1 0?
1.
Okay. So harshly 1. Okay.
1 1.
Yes. Good. At least interesting. Now the word T means toggle. Right? Why this word has come? Right? Let me clarify that. When your previous input is there, zeros, your whatever direct input is coming. If your previous input is 1, it toggles. Did you see? 0 to 1, 1 to 0. It toggled. Depending upon this. This is the game changer. If your previous input is 1, it toggled. If the previous input, I'm using a wrong word, nobody is interrupting. This is the input. If the previous output state, had it been the regular class, all would have shouted. Ma'am, it's output. Right? Okay. If the previous output is 1, it toggled. If the previous output is 0, as it is, you got. That's the word toggle. The clarification and the what? Actual meaning behind toggle is using this states. If zeros are there, input remain as it is. Bring output, next state, and this one remains as it is. If 1 is there, it toggles. Right. So now toggle is nothing but tying the J and K together. This one you can remember. Right. It's very simple to analyze. Okay. Now, what is the next one? So, characteristic equation. Q of t plus 1. Receiving. Q of t plus 1, how much? How much it is?
Q of t plus Q t bar.
So, Q prime t plus
Q t prime plus Q prime t.
t bar Q.
Yes.
So now these are your four important and specified flip-flops. Right. That means these are some of the flip-flops what people have discovered. Right. Now question is, we are fully free to change the circuits also. But remember, the characteristic equations has to be the same. Now tell me, can we change this NOR to NAND? Yes, we can do that. But anyway, as of now, we are not trying to change it. Please have a work out on your SR, basic SR, D, T, JK. All the four flip-flops, their characteristic equation, their characteristic table, and the symbol. Just go through that. Right? Afterwards, we can evaluate for any changes. It's very important. Right? So, JK flip-flop, SR flip-flop, T flip-flop, and D flip-flop. This is how we are trying to, with this only we are trying to analyze what exactly is a sequential circuit. These are the building blocks. Now, if at all I have to tell you, these 0 means what? This is a state. Right? Q of t plus 1 is at 0 state, means with this inputs, Q of t is remaining at the 0 state. Q bar of t plus t is remaining at this state. So we are trying to evaluate the states there. State means it is level. Voltage level is maintained. Okay. So now carefully understand here what exactly is happening. Right? These circuits are, as of now, they are fixed. Right, SR, T, JK and D. Whatever I have taught, those are fixed. Now the analysis is also exactly like that only. Don't change your characteristic equation. This remains the same. Okay, for SR remains the same. SR is what, by the way? SR is what?
Set reset.
No, SR equation. SR equation is what? Yesterday you have done?
Like table.
No, equation. I'm clearly saying equation. What is table?
Ma'am, S
S
plus
S
Q
plus
into
QT
R
R
prime.
plus Q.
S plus R prime Q. That is fixed. So no matter whatever your logic diagram changes, but this has to retain that. So that's why you try to memorize this way only. Okay. Otherwise, afterwards, when we become masters, we will do that changes. I'll teach you how to do that. Now, what about D? D, by the way, we have not done. What is that? Q of t plus 1 is nothing but D only. No? Whatever D is coming, it's a delayed version. Yes or not? Q of t plus
Yes,
1
ma'am.
followed D. Yes.
Yes, ma'am.
Right. So T is already here. What about JK? JK just now you have done. JQ prime plus K bar.
Q.
K prime Q.
Q.
That's what, no? So JQ prime. Right? So now, taking these 4 flip-flops, we will try to now start the analysis of a simple sequential circuit. Now, I will get back to what exactly is a sequential circuit. It is a combination of, or it's a cascaded mode of your combinational circuit. Along with that, we will have this flip-flop circuit, which is nothing but these basic flip-flops we will use, and then try to analyze the whole circuit. Now, here, if at all you see, earlier we don't have time instances. But here we are having timing instances. T plus 1. What is happening to these things? That is what we are trying to evaluate. Is that correct? Is that correct or not?
Yes, ma'am.
Are we evaluating it? Okay. Now, just for your reference, a small work. Okay, let's start. I will show one simple problem. Okay, you can understand that and you can give your inputs in that. Okay, just a second. Just a second. I just wanted to say, show you a diagram. Is that diagram correct or not? You can tell. Very easy to understand also. Now we can do some good work. Okay. Just a second. Horrible. Not so horrible. Network is also horrible. Okay, I am just showing you a small diagram. Okay, now what do you understand from this? You please tell me. Okay. Horrible sounds. I think. Why am I not able to show on share? Right. Now I'm zooming in. Can you see any window? Just a second. I'm just trying to zoom it. Okay. Now something is provided you like this. Right. Can you tell me what is the analysis of this circuit? Yes, everybody are silent. Why? Is this the same thing what you have analyzed and told me? I told to take SR is L stands for latch. Is this the same thing you have told? The two gates can be changed to AND gate and then afterwards a NOT gate over here. Will it work out as a D flip flop?
Yes, ma'am.
And should I use NOR or NAND? Should I use NOR and NAND?
NOR.
Confident? Confident?
Yes,
about
ma'am.
it?
NOR.
No. Okay.
Yes.
Good. Okay. So good. You are at least able to analyze that. Okay. Now let me tell you about a small story of your clock pulse. Okay. Till now the clock pulse is just a signal, and you are telling it is 1. But if you see the word pulse is there, no? What do you mean by pulse? Pulse means it is having a low level as a high level. Alright. And it will stay at two different positions. Right. Now, if you say, take one simple issue, right? It is the reference. Consider this is the reference. Okay. Now, a pulse I will try to draw. Now, pulse means I am taking this particular one. Then afterwards, I'm very bad at it. So, with respect to the reference, I am having an on and off time. Consider I have produced this from a circuit. The signal is there for a circuit, and now I have fixed levels, right? So now this I am taking it as a clock pulse. Now if at all I see here, this particular pulse has three things to be observed. One is I can clearly see an arrow mark from low level to high level. This arrow mark. I can have a drop down one from high level to low level. Is that correct? Take this pulse, low to high, then stay there, and high to low. It is falling down. So that means I have edges which are moving from low to high, and other one is high to low. Did you observe that? Right? Hello?
Yes, ma'am.
Correct? Now,
ma'am.
right. And there is another third one. This is called a standard level. Means at high only it is staying. Right? Third one. So this is number 1, this is number 2, this is number 3. That means a pulse is having a property to have a low to high movement, staying at high for some time, right? And high to low. That comprises of a clock pulse. Now, earlier in your flip-flop analysis, I said keep CP, clock pulse as 1. What do you mean by that? Clock pulse is always maintained 1. So, at that one position only, every drama is going on in the other gates. Is that correct?
Yes, ma'am.
Right. Now tell me, relate to this and tell me at what level it is taking care. Which level the whole scenario is working out in every gates. And in what level the output Q of t plus 1 is analyzed. See, I showed you 3 levels. Just point out 1, 2 or 3.
Three.
Are you people understanding? See, I have a pulse made up of 3 levels. One is moving from low to high. Another one is high to low. Other one is maintained at 3. So now somebody has pointed out it is 3. Can you verify why it is? Because Cp is equal to 1. 1 is always referred for our analysis. It's always high. Right? We are taking that one. So during the high, that means at that level only, we are analyzing Q of t plus 1. Is that correct? You will understand that.
Yes.
Is that correct? Yes. Now, you know what? This the timing diagram is there, no? Timing diagram. With respect to the clock pulse, this is called the reference line. Right? This is the clock pulse. Now, J, K, Example, I am just giving Q of t plus 1. All these things are to be analyzed, right, with respect to this particular pulses. This is called timing diagram. So now at your level, high level only, J is entering the show. So that means we will follow from here to here. At that moment, what is happening? J is high or J is low. We will try to draw that. Okay. So if it is low, we will try to draw like this. Right. Similarly, K. If it is high, we will try to draw like this. Right. What is Q of T? If it is low. If only I tell you. It's not necessary. Right? And what is Q of T plus 1? Within this state change only we will try to analyze. So now with respect to this reference, everything is plotted. This is called timing diagram. Right? Now you should be getting some questions. Seriously understand? I am using only the flat surface of the pulse. Why can't I use now? Did you see? The flat surface is at a different what? Time period. Don't you see the flat surface is very stretched when compared to the low to high and high to low? Low to high and high to low are very spontaneous. No? Did you see? Observe here. Low to high and high to low. Did you see the time gap there? Can you see that? It is very spontaneous. In fact, it is a impulse. Is that correct? Edges are impulse, whereas your standard one is having a stable, right? Stable level. That means for a time stretch it is there. Did you observe third one is like having a time stretch, whereas 1 and 2 don't have any time stretch. Now tell me which one you will prefer. Which level of pulse you want? You always want this one? I mean standard levels, or you can use the edges also.
We can use the edges also.
Right. Now the speed comes into matters. So we want a quick clock pulses to change. That means triggering effects. Immediately the outputs has to change and immediately the process has to continue. So I will in fact say here 2 levels of operation. One is edge operation. The other one is standard operation. Standard is nothing but we are using the flat surface. Okay, whereas edges either low to high, high to low, anything you use. In fact, it is a positive edge, the other one will be a negative edge. So we can have circuits which are working in the flat levels or edge levels. Flat levels are the one which will take the output to deliver in this time duration, whereas the edge levels are the one which will deliver at the edges only. Whenever a change is there, at that level only we will get a change done. We can get the outputs. That means at every reactions, here only it will react. The circuits will react. The other, it will continue to retain in the previous continued state. So we can understand the circuit as 2 issues. Like one is edge triggering, the other one is standard triggering. Right? So till now we have used a standard triggering. Why? Because we are not using any applications. Right now we are in the board work, right? Pen and paper work. So don't worry. When we use the what is the practical, we normally use the edge triggering. If you can see, the time is very impulse. Like we can say we expect quick movements there. Is that correct? Yes or no? So now this is what called edge triggering. You can actually Google also and check out. So edge triggerings and then the reactions of the outputs, right? And moreover, if at all you have time, again go through all the 4 flip-flops, because tomorrow class I will start with the analysis of the sequential circuits. And by the way, tomorrow can I get 9 to 10 slot if possible? Shweta?
We have math.
9 to 10 slot if possible?
We have math class, ma'am.
Yeah.
No, ma'am.
Yeah,
9 to
maths.
10 we are having maths.
Oh, maths. Okay. So 11 to 12.
Yes, ma'am.
As usual.
Maths class.
Okay. 11 to 12 as usual I will take. Okay. Fine. Thank you.
Yes.
Right. I think you have next class. Right. Go on. Okay. Okay, thank you.